All right. So, welcome again, everyone, and thanks for joining us. Today, we are talking about agentic AI in industrial operations. It's a topic that's getting a lot of attention, but in many cases, it still might feel quite abstract. So, what we want to do today is make it practical for you. We'll walk you through what actually that means, what needs to be in place before industrial AI agents can work reliably, and how teams can start moving in this direction. So let me introduce to you. So I'm Shashank Sharma. I'm Director of Product Marketing at HiveMQ. And today we have our special industry guest and our industry expert here with me, Kudzai Manditereza, who's our Senior Industry Solutions Advocate here as well. Kudzai, great to have you here. Please feel free to introduce yourself to our audience today.
Thanks, Shashank. It's great to be with you on this session. Hi, everyone. My name is Kudzai Manditereza. As Shashank mentioned, I'm a senior industrial solutions advocate at HiveMQ. I take care of our thought leadership on the topics of unified namespace, smart manufacturing, and agentic AI, and all the other AI topics. Great to be here.
Thanks, Kudzai. So let's go and dive deep into the agenda first. So let's first of all, at a glance, I'll keep this very, very brief. HiveMQ, as many of you know, focuses on data streaming for industrial environments. We also are providing now a data intelligence layer with HiveMQ Pulse. And today we also want to discuss how that helps you in enabling agentic AI. And yeah, everything we'll discuss today depends on the well-structured data underneath. So it makes sense for us to discuss about this topic. And with that, let's start with the core question. So the core question is why agentic AI needs a new backbone. So there's a lot of excitement around agentic AI, but in industrial environments, the challenge is usually not the model itself, but it's everything around it. So that's why I have Kudzai with me today, and we have with Kudzai. Kudzai, I want to give you again this question. So why can't introduce organization just introduce agents? And why does like agentic AI need a new operations backbone?
Yeah, thanks, Shashank. So, I mean, a good way to kind of like look at why is it that agentic AI needs a backbone is really kind of like looking at what the actual promise of agentic AI, and I think we've seen a lot of approaches where you've seen like some chatbots and you kind of like seen some, dashboard summarizing tools and things like that. And I think that kind of like is not really what the promise of agentic AI is. And that's why a lot of people, when they look at that and then they see and then say, okay, but this is not transformative. Like, kind of like if we're looking at it, sure, it could help you maybe if you're building, say, within an application, like coding or stuff like building some dashboards. But when it comes to helping with your operational tasks, that doesn't help much. But the actual promise of agentic AI is more on decision intelligence. And what do I mean by that? So a good way to look at it is kind of like look at a statistic, that was, published recently by the U.S. Bureau of Labor Statistics that mentions that factory productivity between the periods of 2008 and 2023 has been flat, right? And at some points, it has actually, declined. And if you kind of like look at that, you realize that this is also the period where a lot of companies were digitalizing, adoption of MES systems, IoT platforms, and things like that. So the data access has been there, but the productivity itself has not really improved. So that speaks to, the issue that the data access, yes, it's one issue, but still there is a lack of people who actually have to look at that data and then make sense out of that data and then go on to take decisions which then leads to more productive outcomes. So agentic AI really fills that specific gap where it kind of like allows you to be able to access all of this data all of these conditions across your entire, operations, and be able to recommend, the next steps that an operator or a leader needs to take, sort of like accelerating that decision challenges. I mean, if you look at other industries, for example, in the metals industries, where for a process engineer to get to a point where they could really, confidently take an action based off of data, they need to be there for like 5 years. They need to have kind of like 5 years experience. And that speaks to the shortage of this kind of skill. But this is exactly again that space that agentic AI fills, not the chatbot where you're chatting with your data. That's valuable, but that's not the actual premise of agentic AI. Now, having said that, for you to get to a point where you've got agentic AI actually, investigating a quality failure, tracing a root cause across different systems, and then sort of like providing a prescription to an operator, you need to have these three, things in place. First of all, that infrastructure. Secondly, the intelligence and the trust. And we talk about infrastructure, we talk about this idea that your data need to be unified so that an agent system, for it to actually make a decision that spans across systems, needs to have context that extends outside of a single system. So you need to have that backbone that gives you that unified view, that sort of like unified data platform, as it were. Second step is the intelligence, right? So just looking at data and accessing data again is useful, yes, but it doesn't actually lead to those outcomes that agentic AI promises. So you need to have that intelligence, or rather, you need to add that semantic layer on top of that data to further inform, that agentic AI or those agents. And then obviously the other issue is trust. Again, you need to have a way to actually, we call it trusted delegation. So you need to be able to say, if you say to an agent, prepare a shift report or do A, B, C, and D, you need to have, the confidence that it can actually execute that repeatedly, consistently. So again, you need to be able to trust these systems. So these are the three pillars that we're actually going to dive into in this session, to kind of like explain to you exactly how do you get to that level where you're able to operationalize agentic AI. Back to you,
Thanks.
Shashank.
Yeah, thanks a ton, Kudzai. So I like hit on a very important point. So the limitations, in my opinion, are not capability, but the environment that supports the data, whether data has actually meaning or whether there are guardrails to trust the system. So it begs the question that if the issue is missing backbone, then what does this backbone actually looks like? So Kudzai, I think you have a multi-step blueprint. Can I ask you to help us walk through, like you mentioned that you can build that with MQTT and UNS, and if people know you, you talk about this a lot, so this is not a new topic for you. Why is it so important? If you can just briefly again walk through everybody in this round, and then how does this is shift from traditional integrations to something like UNS, which is based on MQTT? What's possible? So, just give us your perspective on how does it look like and why is it so important?
Absolutely. Okay, so this is step one of the blueprint, right? And before we kind of like dive into these four steps that we have outlined there, I think this is a timely conversation, because if you kind of like have been paying attention to LinkedIn or some other media outlets here, there's kind of like been a conversation that you don't actually need a unified namespace, or you don't need real-time data for your AI agents. We talk about knowledge graphs. We talk about an agent could go to a historian, or agent could go to a database and get all of that information. Sure, we're going to talk about that later on, but this kind of like really misses the point that, I mean, if you look at manufacturing, real world manufacturing, every single workflow starts with an event, right? So whether it's an order that is being generated, that's an event, and then whatever workflow needs to happen after that is based off of that start time is that event. When quality inspection has been completed, there's a certain workflow that happens after that. That's an event. So if agentic AI is to kind of like work as a digital teammate or sort of like augment decision making, it has to work off of that, event framework where it listens on a specific event. It has to have an operational starting point, a live starting point. So the unified namespace is that first, is that, that business context that gives you the current state of your entire business. And it is that place where the agent plugs in to listen in on the events to say, this is an event that has just happened. And then it goes off and does whatever workflow it needs to, whether it is going to an MES system, reading from a database, accessing, a graph database, all these other things that then sort of like enriches the agent's context happens after an event has been raised. So that real-time data foundation is the very first step that you need to have within your architecture. Sure, you'd have all these other ones, but it's a layered architecture. And so for you to get to that point where you've got that real-time data foundation where you are, providing access into your agent with real-time events, so obviously you need the very first step is that if you've got any manual, processes or any paper-based, processes, the very first step is kind of like digitize that. So that means onboarding all of your assets, those assets that don't already communicate in an IoT protocol or a protocol that makes it easy for integration between OT and IT. That is the very first step that you need to be able to do is to digitize that. And in this case, you really need to adopt a tool that allows you to digitize, at scale, right? So because we know obviously you could, talk about, okay, I could write, a custom Python script to connect to that, or I could, use Excel spreadsheet and things like that. But as many of you on this call know, it's really hard to scale those in a way that allows you to onboard your assets, faster. And then once you've done that, onboarding of assets into your digital infrastructure, then you need to adopt that event-driven streaming architecture, event-driven streaming that is based off of an event-driven architecture. So essentially, what that means is that you've got a broker, a message broker, to which all of these, assets or these systems, operational systems that you've digitized are plugged into. So you're running away from this idea of point-to-point integrations. Again, we mentioned this idea that if you do point-to-point, you still retain those data silos. You don't have that unified view or that unified, sort of like data platform that allows agents to, tap off of that. And then again, you also need to have, that platform for generating these events that work, as triggers for agentic workflows, as it were. So this step of adopting an event-driven architecture, you need to sort of like build that, data contextualization pipeline because you're collecting this data as, raw, tags from your PLCs or your machines, and then you put it through a, some call it data ops, that pipeline that then, pushes that data up to your event backbone, which is your MQTT platform. And then within the MQTT platform, the very first step is really to organize, your data semantically so that it represents the current state of the business. So at any point, whenever an agent plugs into your infrastructure or unified namespace infrastructure, it needs to understand semantically what it is, it is looking at, right? So again, I think many of you already know about unified namespace, where you've got the semantic arrangement of your events, your states, and the definition of the systems within your infrastructure in a semantic fashion, normalized, contextualized. And then from there, this could then be made available to the agents as that real-time foundation where they can see what equipment do I have within my infrastructure, what is the current state of each piece of equipment, and what are the events that are emanating from all these different pieces of equipment to then be able to implement those agentic workflows.
Mhm. Thanks, Kudzai, for this detailed explanation. So I agree, like, instead of system talking to each other in isolation, everything publishes into a common structure like a UNS, then that agents can consume. And Kudzai, you mentioned this like at the end, and I want you to like dig a little bit deeper. So, you mentioned that agents still need to understand the data. And that's my question, like, how do they understand it? And also, I think in the step two, you will talk about ontologies and semantic graphs. So maybe can I ask you, can you, for everybody in the room, please make it simple, help us simply understand uh, what are these and how do they help?
Yes, 100%. So now you've got your data flowing. So that's step one. You've got your data flowing, event-driven, streaming through the MQTT platform. Now the next step, this is kind of like this layer two of this architecture that I spoke about, um, where okay, so I think someone is asking if there's an echo in the audio. Just let me know if this is coming from my end, Shashank, but I'll
Uh,
carry
I,
on
I hear
regardless.
your audio pretty well, so I don't have any issue at my end.
Okay, perfect. So, the step two are kind of like talking about the next layer within your architecture. So we have got the unified namespace or the data streaming layer. The next layer is, persistence, right? You're persisting this state, you're persisting this definition, and then you're persisting these events, so that the agents actually can then have more context where it could kind of like look at data from a historical perspective. But this is kind of like where knowledge graphs and ontologies come into the picture. So basically, kind of like here, what I want to do is to help you understand exactly how knowledge graph or what they are or how they fit into this picture, as it were. So first of all, why do we need to adopt knowledge graphs? The first thing is let's kind of like consider something that everyone here will almost be familiar with your relational data storage, your kind of like a SQL based databases where you've got different tables, and then maybe you may have all these different tables or entities being joined by foreign keys. So for you to actually get context, to understand, to get a full picture of exactly what's going on across your entire operations, you'd have to create multiple joins, like you come up with multiple sophisticated join, statements that connect this, product information to this quality information to this and that. And in even for a human, sort of like a consumer of data, that is already a huge, because first of all it requires that skill for you to be able to understand all of this. Secondly, performance wise, it's not very friendly, but more importantly it is not an intuitive way of really understanding data or the connections between your entities within your operations. So knowledge graphs, particularly because most of or graph databases rather, particularly because most of them are based on this property graph model where you're able to define entities and then assign labels to those entities and then also come up with relationships that are typed. You've got different types of relationships and you've got directions for each relationship, right? That allows you to create this graphical connection between your entire entities in a way that makes the data self-explanatory. So when an agent or even a human is actually, going through a graph database or traversing database, they can actually make connections from one entity to the next without, needing to have that explanation or needing to know exactly what to join, which table to join. So it gives that intuitive access to the data. So that's why the very next approach is to have an intuitive or rather a different way of organizing data, and knowledge graphs which leverage this property graph model within the graph databases that allows you to then define those relationships, specify their direction. So for example, if you want to say a batch consumes a material, you can then specify the batch as an entity, and then consumes is a relationship between a batch and a material, and we've got a direction that actually material is moving from from a tank to whatever equipment is making that batch. So you can define those specific entities, connections, and relationships. And when you define those, you come up with a knowledge graph. And then that knowledge graph, when you instantiate it, it then lives within a graph database because it maps to that property graph model. But that is step one, right? That kind of like is step one of organizing your data. So you can organize your data. So again, I mentioned this idea that you can say an order has been completed or an order is complete, but these are in as much as an agent will be able to traverse the graph database and make those connections intuitively, understanding the semantics of that is another thing altogether. So if we are operators in a manufacturing facility, if I say to you, and this order is completed, based on the context in which we are actually, operating in, we can both understand exactly what we mean. So if we are maybe in a maintenance team, we know this is actually a maintenance work order. If we are, a production team, we know this is a production work order. And completed, in many cases, we know that if it's completed, this is actually, been handed off to, to inventory and things like that. These are nuances that, as operators or as humans we've come to agree to, or if you join a company you get to understand exactly what all those means, but an agent doesn't have that understanding. That's why it needs to be encoded in machine readable format. This is where an ontology comes into the picture, where a relationship, if you define a relationship to say a batch consumes A, what does consumes actually mean? What does it mean to consume something, right? So this is what you specify as an ontology to say consumes means this, a batch means this, an order means this. So you're removing all the ambiguities within your sort of like your data or your database. So an ontology becomes that blueprint where you define all these categories, all these relationships, and then your knowledge graph becomes the concrete realization of those entities, and then your graph database becomes the actual data, the actual system, the physical storage of all of this data. So step two of your blueprint is then establishing that data storage and organizing it in a way that makes it intuitively for agents, which means that you're adopting the knowledge graph, and then you're also building an ontology on top of that knowledge graph.
Thanks, Kudzai. So, like, if I have to summarize, like the very detailed and very helpful explanation, you said the UNS gives structure, but the semantic layer gives us meaning. And the semantic layer defines relationships, constraints, cause and effects, and it allows agents to reason across the system, right? So once this foundation is in place, the question becomes more practical, and that usually is, okay, great, like where do I begin? So, Kodzai, where do you see typically the fastest path to value for agentic AI in industrial environments? So, yeah, please walk us through.
Yeah, absolutely. So agentic AI, gives you capability. So as as we would understand, but obviously capability alone doesn't automatically translate to business outcomes, right? So you should kind of like think about where do you want to deploy agentic AI, and at what level of autonomy, and what is the expected return from that. So the business value for agentic AI really center around these four value domains, right? So you've got your production continuity, basically where the opportunity there is to use agentic AI to maximize operating time, right? And then we've got throughput optimization, and there the opposite, the kind of like opportunity for agentic AI is really to maximize output from your existing capacity. And then with things like resource efficiency, which again is minimizing operational cost. And also we've got quality assurance, which makes sure that you achieve that spec target consistently. So kind of like thinking about looking at these four value domains, and sort of like so within these obviously there are some even more granular use cases that you could go into within production continuity, or within quality assurance, to find out exactly how best could we maximize operating time from this. And then once you pick that use case, you then build your sort of like you connect whatever asset is that you're building that agentic workflow for, and then you stream that data, you structure it within a unified namespace. And the nice thing about all of this is that this is bottom up, right? You're not sitting to because a mistake also that happens is that a lot of companies think they're going to sit down and build an entire ontology, that this is our entire enterprise. That's definitely not going to happen. Actually, by the time you sort of like complete that ontology, in many cases the case for whatever use case that you want to solve likely will not even be there anymore, right? So you want to be very agile. And the nice thing about knowledge graphs is that they are not um, it's not a rigid schema. It allows you to really build these ontologies from the ground up. So within a quality domain or within a specific, a more granular, operation domain, you can start to define what are those, terms, what are those terms that, could help us really understand what, downtime is, right? And then start to collect that data, put it into a unified namespace, and then create those semantic graphs, those relationships, and then from there start to implement those agentic workflows to sort of like maximize the operating time. And then while you do that, you also want to pay attention to um, the autonomy, the maturity levels for your autonomy, right? And basically, the best way to look at it is the first of all is step one is diagnostic intelligence. So maybe you want to build an agent that just monitors, right, and generates alerts, right? So maybe it monitors to say if equipment A and equipment B are down at the same time and such a thing is happening, then do this. Because we know that in many cases, this is something that a lot of organizations actually don't even have that ability, that visibility to actually, look at three different systems, perform some, correlations and generate alerts. Sometimes, you have to go physically to all of these, different domains, get that information, and then, send that alert to whoever needs to happen. So that is a very step, level of maturity where you've got that agentic system that just does that and provides value out of the box. And then the next step of maturity could be, your prescriptive, intelligence, right? So basically, you're using your agentic workflow to recommend the next steps. So this obviously requires the agent to sort of like have access again to that backbone to look at, a perfect example here is kind of like really, looking at root cause analysis, right? What, caused this, what systems are happening, and then for you to actually get the optimal result or to fix this creeper, this is what you perhaps need to look at first. Kind of like doing those recommendations could be that next level of autonomy. And then, you know, autonomous, again, this is a level that a lot of companies are still really far off, getting to that point where you can really, have those agentic systems taking autonomous decisions. But again, autonomous decisions have got different, levels of risk again. So, autonomous decision to, prepare a shift report may be not as disastrous as an autonomous decision to actually, change a set point, right? So those you kind of have to come up with a way of creating those levels of autonomy for your agentic systems, and then build a use case, take that use case through those levels of autonomy.
Thanks a lot, Kudzai. So maybe like just to quickly dive a little bit deep. So you talk about autonomy maturity. Can you help us walk through one simple example? Let's say one example in production continuity, and then you just take one concrete example and walk our viewers through the three autonomy maturity that you just described.
Yeah, absolutely. Yeah, so I kind of like as I mentioned, the first step, like the low level, of maturity is really kind of like just monitoring streams. So maybe yeah, you're detecting anomalies, right? So maybe you're detecting that this equipment is about to break, or whatever it is that you are monitoring, for a specific piece of equipment. That could be, your level one. So and then your level two. So maybe the recommendation that you want to do is to say, shut this equipment down or do that. But before you do that, you need to understand those dependencies. What else within your line or your operational domain depends on this equipment being shut down? Is there any upstream service that is going to be affected? And then being able to recommend across the board to say, because this one is being shut down, this needs to happen and that needs to happen and that needs to happen. So yeah, the idea is we are really trying to to sort of maximize our operating time to say, even if you're bringing things down, you kind of like you have to have some contingencies within put in place. And then obviously you kind of like really also again at another level you can identify those risk to production schedules, right? Is there a customer who's going to be affected, by this action that I'm about to recommend? And if you think about it, currently, in a traditional approach, it will take you really 45 minutes to an hour, or sometimes hours, to really get that kind of intelligence of understanding. Is there any customer who's going to be affected by this action that I'm about to take? Or is there any downstream system that depends on this? So really having an automation, or rather an agentic, workflow that allows you to be able to, consider this, or sort of like take into account all of these things, and then make a recommendation. That's already, a very powerful way of really, maximizing operation time. At the same time, making sure that you sort of like maintain your customer experience. You have a good, customer experience, and you may also want to look into your inventory to say, before I even, recommend this machine to be, shut down, do we even have, parts within our inventory that we could actually use for this, or do we need to order these parts? So kind of like getting that whole context that in many cases takes a long time for people to put together. That's where you get a lot of value from agentic AI.
Thanks a lot, Kudzai. So the key takeaway is actually there are two. That where start where the data already is relatively mature, where the value is easy to realize, and then progress through the stages of autonomy rather than jumping straight into the boiling pan. And yeah, and you'd know how fast you can progress through it. So thanks a lot, Kudzai. And now once we start thinking about the real use case, like the question that begs is, what do these agents look like? So, Kudzai, do we have anything on that help us, like our viewers, understand what would these agents be looking like? Do we have some examples?
Yes, yes, yes. So I think if you go to the next slide here, we've got some example, taxonomy of agents, right? So, I mean, once you build a strategic direction, in the previous slides, and then once you've got that, you need to have some granular view of exactly what agent am I going to build for what specific use cases. And a good way of looking at it, is this kind of like different a taxonomy of the different kinds of agents that you could build to achieve all these different, or to address all these, different use cases. So the first, group of agents. So again, this, some companies would approach this, differently. Some would want to create maybe a digital twin, right? They want to create a digital twin agent for a piece of equipment, or they want to create a digital twin for each work order. So each time you spin up a work order, you want a digital twin that follows that work order throughout the entire process, and kind of like generate events, and kind of like generate all of this awareness. But sort of like a more high level top down view of, approaching this is kind of like look at these, for at least four different buckets, where you've got a monitoring agent, right? So a monitoring agent, basically its role is kind of like do a continuous state assessment, right? So this is about establishing that real-time awareness of operational conditions. So again, this is plugged into a unified namespace, maybe aggregating data, making decisions. That's kind of like getting that, you know, real-time awareness of exactly what's happening, and then taking actions there. So whether it's, say, generating an alert, or sending, or a recommendation, or whatever it is. And then we've got diagnostics agents. So basically, these are more root cause determination. And frankly, this is where I've seen a lot of companies moving towards. This is where the biggest value is, kind of like that root cause, determination. Why, did such and such a thing happen? Because in many cases, this is something that takes a long time for people to really get to the bottom of it. Exactly why did this, quality go bad here? And in many cases, the answer may not, come from one system, because you need a whole lot more context for you to make that, a determination. So again, diagnostic agents, their, purpose really is to do that root cause determination. So when your monitoring agents detect so an issue, and then diagnostic agents can then get that in as an event. So you've got these multiple agents coordinating, and then when a diagnostic agent gets an event that such and such a condition has happened, a diagnostic agent will then go on to find out what is the root cause of that, and then be able to come up with an assessment. And then you've got your predictive and optimization agents. So basically, outcome forecasting, right? You want to project future conditions based on current state and historical patterns. So that would obviously enable you to proactively intervene before, a much bigger problems manifest in a way. And then you've got coordination or rather learning agents, because if you are going to have multiple agents here within your environment, you need to have a way of actually coordinating them, especially if you've got like a goal-directed objective. So you want to be able to coordinate all of these different agents to work towards that one common goal and be able to learn from if a root cause actually was determined and then an operator actually performed an action to fix that, then that needs to be learned and actually enforced within your knowledge graph, such that when that same thing happens again, the agent would actually be able to actually determine to say, you know what, this may be the first thing that you want to look at because same thing happened and this was the thing that resolved it.
Mhm. Uh, Thanks a lot, Kudzai, for this detailed breakdown. I'm pretty sure a lot of our viewers will find it very useful. So instead of using one system, which is sort of black box, we are talking really about a set of specialized roles, and you can have breakdown agents into monitoring, diagnosis, prediction, optimization, coordination, and orchestration, etc. But now you must be thinking that as soon as we are talking about agents which are starting to influence the real operations, so when we start talking about real operations, the governance becomes critical. And now we are now moving into the more sensitive area. So, Kudzai, how should the organizations approach governance for the industrial AI agents, especially when the agents start affecting production or safety?
Yes, 100%. So I mean, deploying agents within high stakes environment. I would like to believe our audience here, since the topic here is really about agentic AI for industrial operations. Our audience has got already an awareness of exactly what's at stake, as far as not putting in place those governance frameworks for AI agents or agentic AI, or what could be the consequences of having that not properly put in place. So again, to your point, for organizations to be able to harness the power of agentic AI and still maintain the control, they need to kind of like come up with this framework, rather, or a governance framework, a robust governance framework that allows to, confidently implement agentic AI. So, like kind of like to separate this into three buckets, as it were. So the very first phase is kind of like really be able to design for control. So what does that mean to say you're designing for control? So the very first step is to say you have to have a clear agent ownership, just like how you have ownership for assets or for system. You've got a maintenance team, taking ownership of specific operational systems. You've got a quality team taking ownership of specific um, um, operational system. Same applies to AI agents. They need to have, that, accountability or ownership accountability, as it were, where the owners are able to determine what is prohibited as domain experts. So obviously working with, the IT or whoever is, implementing that, but that, determination of saying what actions are prohibited, or which actions actually require human approval. What are the different steps? What are the escalation paths that need to happen for us to operationalize agentic AI? So kind of like really building for that control, or even performance quality. How do you actually know that an agent is actually performing? What are the metrics, right? Or what are the thresholds that would actually trigger a review by a human inspector? Those are things that are only understood by those domain experts. So it makes sense for them to take ownership of those agents. And then again, we spoke about this idea of having de-risking tiers, where you specify your agents, you put them into categories, whether these are monitoring and alerting agents. These ones are only going to be monitoring and alerting. And then you've got recommendation with human approval, and then you've got constrained, autonomous actions if you want to do autonomous actions. So coming up with those tiers to de-risk and gradually promote the agents. So if the goal is to get to recommendation, start by just monitoring and alerting, so that you establish trust, right? So if an agent consistently actually alerts, correctly, then the domain experts would be able to approve it to actually go more into recommending actions. But if it actually does, a bad alert, if it gets it wrong, then the domain experts will actually know that actually this is not actually ready to recommend, based on exactly what it is, the criteria that they're using. So having that agent ownership is very crucial. And then the other issue is the phase two is engineering those technical controls. So these are like your hard sort of like constraints, just like with the PLC or machine systems, you've got that e-stop, you've got that emergency stop because you understand that anything could actually go wrong. Same thing with agents. Agents need to have that e-stop. You need to be able to sort of like stop an agent doing its workflow, right? So those guardrails that need to be there. Again, you need to have those ability to roll back capabilities, right? So if an agent does something, you need to be able to actually have a way of rolling back that action. So these are kind of like those technical guardrails. And then obviously again that operate with oversight, really, having human supervision as backed into the agentic workflow, not really as a fallback, but rather kind of like side by side operation of a human leader, a frontline operator working side by side with an AI agent. So I would say kind of like those frameworks. So obviously they go much into much detail, but kind of like thinking about these, within these four buckets is very useful. It's very useful because also it's a different, especially when you go to technical controls, it's a different way of governing because it's a different new threat vector. So right now you've got things like prompt poisoning, right? This is something that not even the IT teams are in many cases empowered to sort of like guard against, right? Those are things that you kind of like need to look at that. Okay, what exactly is allowed, or how what are we guarding against as far as this agent is concerned?
Okay. And like what I am understanding is governance is not something you can add later, right, Kudzai? And it has to be designed and enforced and maintained as we go through this digital transformation journey to enable agentic operations. Uh, but I believe that would lead to a broader shift just beyond the technology, right? And this is where probably things starts to move away from simply an architectural change to more like an operational change. So, Kudza, if we move towards more distributed, multi-agent, intelligent systems, how do we ensure everything stays aligned to business outcomes?
Yeah, so once we've spoken about this idea of different agents, we've got a monitoring agent, we've got a root cause agent, we've got all these agents that are executing specific tasks. But if you understand exactly how value is generated in industrial operations, you know that the most valuable challenges are those that are not really solved by silos, right? They're not solved by specific individuals or within a constrained environment. Same applies to agentic operations. The most valuable challenges are not those that can be solved by one agent just operating in isolation. Sure, you could get some performance improvement by having a localized agent perform a specific task, but to really transform an organization, to really get those transformative changes, you're going to actually have all these agents collaborating across your entire operational domain. Like for example, obviously your production throughput depends on equipment availability, which depends on maintenance execution. So if your maintenance execution is not keeping up, so it affects your sort of like your equipment availability, which affects your production throughput, which also, again, I spoke about this idea that this also depends on part inventory, right? And your part inventory depends on supply chain coordination. So all these are interlinked, right? So for you to really get a transformative output or a transformative outcome for your organizations from agentic AI, you're going to have a way of sort of like having these agents coordinate, across that, backbone again that we spoke about. And if you look at how this is being, done, this kind of collaboration is being executed currently within manufacturing, is still based off of it's more of a result of ISA 95, where the state-driven architecture, whereby you've got your level one systems or your level zero systems that operate within maybe milliseconds, and then you've got your level two system that operate within seconds. So all the events of level one, they aggregated as a state to level two. All events of level two, they aggregated as a state to level three, and then at that time it's now in the order of days. And then by the time you get to level four, you're now looking at things from a quarterly, perspective, right? And so your agentic systems are not able to take corrective decisions based off of such a kind of architecture where events are aggregated into states, sort of like milestone-based approach to looking at data, right? Rather, what you want to do is actually, have all this, collaboration based off of an event-driven model. As and when an event happens, right? You want to be able to adjust your production schedules based on what is currently happening on the shop floor. Because in many cases, as soon as an order leaves the ERP system, the business is blind to exactly what's going on the shop floor. It doesn't actually know what's going on the shop floor. Yet there are so many events that affect the outcome of that, a business outcome that the system doesn't have visibility to. So the kind of like means that you need to have those agents coordinating based on an event driven model for you to be able to get those transformative outcomes. And what that translates to is kind of like looking at it in a way where the shared intent again is more important than a local KPI. So instead of, yes, you are going to optimize for machine uptime, that gives you that value upfront. You're going to optimize for batch yield and all these maintenance intervals, but on top of that you need to have that coordination layer that sort of like makes these different separate domains coordinate to achieve an objective function as it were. And then obviously common context. I think we've spoken about this at length, that you need to have that common context for you to be able to actually, be able to coordinate to make these agents able to coordinate against each other. So actually I did write a white paper on agentic AI collaboration over MQTT. So we were going to provide links again to this, which is separate again from this blueprint, where that speaks about how to actually make AI agents collaborate. How to build that framework that enables AI agents to collaborate.
Thank you, Kudzai. And I think like just to make it concrete, it's very intentional. So we need to be intentional about making sure that there is a common context and shared intent while building such an operating model, right? And now moving to from like discussing theory, let's talk about how we can implement this in practice. So now, let me briefly map you this to the HiveMQ platform. So, HiveMQ, for those who are new, we are an enterprise industrial AI platform. At the core, we have our data streaming capabilities, which we can. So, in the data streaming, our core product is HiveMQ Enterprise Broker, which many of you know and love. We also have HiveMQ Edge, which is our edge software gateway where we can bring in this different sort of varied industrial data into MQTT. And together we form a data streaming layer. Now, once you have the data streaming in, you need to transform it, make it AI ready. And somebody asked this question: how can we make sure that the data is not raw? So that's where HiveMQ Data Hub, which is actually part of the broker, and HiveMQ Pulse, which is our semantic layer on top. So with Data Hub, we can do start checking schemas and bringing in like a bit more governance, simple governance around data normalization, rules, and policy enforcement on the workloads. And Our HiveMQ Pulse is the data distributed data intelligence layer on top, which helps you govern now your unified namespace and provide you observability across the systems like agents, teams, operations. So if you are a big organization with multiple plants running in and you need to have a visibility and a shared semantic layer, then HiveMQ Pulse is kind of thing that you'd need. And Kudzai, from your perspective, how does this maps into the three layers that we've been discussing so far?
Yeah, absolutely. So I think it's also a good, point to also address some of the questions. So I see, there's some, questions here on the chat here that are asking, specifically about that. So, for example, here we've got a question from Ego that says, "How do you build semantic layer on top of the unified namespace?" So, if you'd uh, maybe no. So basically, we've got the data streaming layer, which is your MQTT platform, HiveMQ MQTT platform, which is basically what we've been known for all along. And then recently, we also launched HiveMQ Pulse. So HiveMQ Pulse is that layer on top of the data streaming that it's not a new way of ingesting data. You're working off of the same data that you ingested into your data streaming platform. And then from there, you're then able to then build those semantic graphs, those connections, that semantic layer, that ontology that then allows you to be able to make sense of that data streaming that is happening at the data streaming layer. So those three layers is data streaming and then data intelligence with HiveMQ Pulse. And then on top of that, we've got the agentic operations, which then provides those guardrails, those guardrails that enable you to implement, that trusted delegation that I was speaking about, to be able to build, your agents and be able to be confidently sure that they're going to operate within, those specific guardrails.
Yeah, no, thanks. And the other key point is maturity. So data streaming layer is proven. We have proven use cases across the industry. The intelligence layer is emerging and becoming critical in operations, and the agentic layer depends on getting those first two layers right. So this is where we feel a lot of use case that we can support in the future. So with that, let's bring down to what teams should actually do. So Kudzai, if somebody is listening to you today and wants to start moving in this direction, what would be your brief advice? And keep in mind, we have just 5 minutes. So yeah,
Yeah.
please summarize what you would like people to take away from this webinar.
100%. So I would say, I think while we still have everyone on this call right now, or if you're watching this as a pre-recording or as a on-demand recording, this all of these concepts are actually in a white paper that we put out sometime last year. Is still available on our website. So I would say the very first step, if you want to go more into detail of all these concepts that we have been talking about, of all these blueprint recommendations, you download that white paper. So these slides are going to be made available to you, and then you can use that download link there, or you could go straight to our website and search for the blueprint for agentic AI in industrial operations. You should be able to get that white paper and download it, and then you're able to kind of like really walk through all of these steps. But just briefly, obviously, you assess and prioritize. I think we spoke about this idea of identifying use cases, and then you implement that backbone, which starts from your digitalization, streaming, event-driven architecture, unified namespace, semantic layer, and things like that. And then from there, you then start to build, your agents and deploy them, and then scale with governance. So I would say the very first step is kind of like getting that blueprint, and then taking it from there.
Uh, Thanks, Kudzai. So with that, we move to Q&A. Thanks everybody for listening so far. And now I will start with some questions. We've gotten a lot of questions, so let's start. So I think Kudzai, I'll quickly answer the first question myself. So it's from Kevin, and it says that how do you see the role of broker in enforcing data contracts or schema validation within the UNS to ensure when an AI agent triggers an action, it's not just reacting to a raw value? So Kevin, thanks for asking this. We had in our two slides before when we talked about how HiveMQ helps enable it. We did mention it. So normally MQTT on itself does not change the payload, but in Broker, we have on top a solution built in called HiveMQ Data Hub. And also with HiveMQ Pulse, we can really enforce the not just the schemas but also specific complex policies on the incoming messages so that you can ensure that your schema behaves as like your payload behaves as expected, and you can also create rules for triggering what happens if the data is incorrect or if the schema is incorrect. So this helps you keep the data quality quite high while the data is in motion. So we do have those options both in with HiveMQ Data Hub and HiveMQ Pulse. Uh, we also have one question which came quite early in the session. So it's asked from Guillermo. So Guillermo asked that, hey, please, which communication redundancy do you implement in structured and changing environments like on-site construction to ensure AI agents are active 24/7? Because I would hand it over to you. It feels like this is a question is answered by the summary of the webinar to me, but please feel free to give your opinion on the answer and like what do you think about it?
Yeah, absolutely. So yeah, it is, answered within that summary of the webinar, but more specifically, if I understand your question correctly, there is the communication redundancy that HiveMQ as the backbone uses is the clustering mechanism. So it's not a it's not a redundancy as it were, where you've got like two brokers, one broker taking over when one falls, but it is really this clustering where you've got multiple nodes that are all exposed at that one logical endpoint for high availability. This is frankly, the reason why HiveMQ exists, right? That specific, a lot of enterprise companies use HiveMQ for that very reason that, guaranteed zero message loss. And, you've got your guaranteed around the availability of, the broker itself. So definitely you're going to have your agents or your agent ecosystem operating 24/7.
Mhm. So in interest of time, I think I do want to answer some really straightforward questions. So slides will be shared with everybody. So yes, and also the recording will be made to host. Um, I want to make clear like one important thing. So in all of the use cases where we discussed data intelligence, data does not go into any system outside where you are operating the data. So for example, it will not go outside factories. So I just want to make sure, and we can't cover this in detail in the remaining session, but we have written blogs on how we go about distributed data intelligence. So please feel free to learn about that. Any other thing, Kudzai, you'd like to address before we say bye? And unfortunately, we do not have time to respond to other questions.
Yeah. So I think 1 minute, to go, I'll quickly answer a few questions from Ronak. Is there an ontology available to use in HiveMQ? So stay tuned. We're going to be putting out some examples for you to look at. And then Joel, will this slide deck be shared? Yes, that slide deck will be shared in the recording. Check our YouTube channel. And then, yeah, for all the other questions that we didn't answer, if you need some more details, feel free to reach out to us. We're more than happy to set something up and provide some more details. So thanks again, everyone, for watching. This brings us to the end of the webinar.